Hi, 7th grade. Welcome to lesson 8-9, Solve Problems Involving Volume. This is your last lesson of topic 8 and also your last lesson of 7th grade. Congrats! By the end of the lesson, I want you to be able to say, I can use the area of the base of a three-dimensional figure to find its volume. Volunteers at a local food pantry pack boxes of soup into the crates. How many boxes of soup will fill each crate? Show your work. Well, if there's a box of soup that's 6 inches tall, we can stack 2 on top of each other, and that would make 12 inches. And it's 2 inches wide, so how many can we fit in 18 inches? So we can fit 2 on the top. In 18 divided by 2 is equal to 9, which means we can fit 9 along this edge. And how far back can we stack them? Well, they're each 4 inches, and there's 12 inches. So 4 plus 4 plus 4 gives us 12. So we can fit 2 going up and down, times 9 going from front to back, times 3, which is side to side. So 2 times 9 times 3. 2 times 9 is 18 times 3. We could fit 54 boxes. Another way I could think of this is to find the volume of that crate. Volume is length times width times height. So the volume of that crate would be, and I can't even see what this was before. 12 times 18 times 12. So get out my calculator. 12 times 18 times 12 gives us 2,592. And then we find the volume of one box is 6 times 2 times 4, length times width times height. 6 times 2 times 4 equals 48. And then we divide 2,592 by 48. And we again get 54 boxes. So both ways work. The second way is kind of leading us into today's lesson. Focus on math practices. A supplier donated crates to the food pantry that are 15 inches long instead of 18 inches long. All other dimensions are the same. What is the greatest number of boxes of soup that will fill the donated crates? How will the volume of the soup vary from the total volume of the crate? So volume again, length times width times height. The volume of the crate is now 15 instead of 18. So 15 times 12 times 12. Get out my calculator. That gives us 2,160. We knew the volume would decrease for the big crate. Again, we can do the math. 2,160 divided by 48. So 48 is that volume of one box of soup. And that now gives us 45 boxes that we could pack. All right, example number 1. Find the volume of prisms. Cora has a tank aquarium with exotic fish. This tank is the size and the shape of a trapezoidal prism. The distance from the front glass to the back is 2 feet. What is the volume of the aquarium tank? So first, it's called a trapezoidal prism because the area of the base is a trapezoid, or the shape of the base is a trapezoid. So our first step is to find the area of that base. So they use the area formula 1/2 base 1 plus base 2 times the height. So here's our base 1 is 3, base 2 is 6. So they do 3 plus 6, which gives us 9. Then we have 9 times 2, which is 18, but half of that is 9. So the area of the base is 9 feet. Now, in order to find the volume of the prism, volume means the whole thing inside. Well, the volume of this prism is just made up of a bunch of trapezoids stacked on top of each other. And how many trapezoids are there? Well, it depends on how high it is. So all we do is take the area of the base, which we just found to be 9, and multiply it by the height. Well, we see here the height is 5. So we take that 9 times 5. The volume is measured in cubic units, so it's 45 feet cubed. What is the volume of the triangular prism? So the first thing they show us the volume, big B, stands for area of the base. So the base here, if we were to stand this up, the base would be a triangle. And the height is 14. That's how many triangles they would stack in there to fill up the entire shape, 14 of them. So the first thing we need to do is find the area of the triangle. Remember, area of a triangle is 1/2 base times height. So area is 1/2 6 times 8. 6 times 8 is 48. And half of 48 is 24. So the area of the big B, the base, is 24. Oh, they wanted us to fill this out just like we already did. 1/2 6 times 8. 1/2 6 times 8 is 24. And our height, how many triangles can we stack, is 14. So then the last step to do is 24 times 14. So that is 336 cubic centimeters. What is the shape of the base of the figure? What are its dimensions? Well, the shape of the base of the figure is a triangle. And the triangle's dimensions, the base is, it's actually a right triangle. The dimensions, the base is 8 and the height is 6 centimeters. Example number 2. Solve problems involving volume. Students are selling a souvenir basketball. Will the basketball fit inside the gift box that has a regular hexagonal base so that the lid fits on top? So first we need to figure out the area of the gift box. Well, same thing. Remember, area is big B times H, where big B is the area of our base. Well, our base is a hexagon, and a hexagon is made up of 6 triangles. You can see the 6 triangles. So all we have to do is find the area of one triangle and multiply it by 6. So 1/2 base times height, the base is 4, and the height is 3.5. So they're going to do 1/2, 4 times 3.5 to get 42. So the area of the base is 42. And the volume of the entire thing, so we already have volume. We need to find the height. So the volume of the entire thing is 294. And we know that the area of the base is 42. We just found that. So we're trying to find the height. We divide both sides by 42. So the height is 7. If the height is 7 and the basketball's diameter is 6 inches, will the basketball fit? Both the height and the width are greater than the diameter of the basketball, so the basketball will fit, and the lid will fit on top of the box. Example 3. Find volume of composite figures. Remember that word composite means it's made up of more than one. So if you can see here, we've got a cube, and we've got a triangular prism. So we need to find the volume of both pieces. And then remember, composite figures, we add them together at the end. So the volume of the bottom section is a cube. You should know length times width times height, or big B times H. The base is a square. That's 18 by 18. So 18 times 18, length times width, times the height is 18. So the volume of the cube is 5,832 cubic feet. The volume of the top section, volume equals big B times H. The big B, the area of the base, our base is a triangle. So you have to use 1/2 base times height. Here's our 1/2. The base is 18 and the height is 10 times the height of the actual prism. So how many triangles would it take to fill this up? And that again is 18. Multiply that, you get 1,620 cubic feet. Last step is to add them together. The total volume of the shed is 7,452 cubic feet. Let's try it. Amber built a custom terrarium for her plants. What is the volume of the terrarium? So it's a composite figure again. So let's break this figure up into 2 figures that we know well. So I see 2 rectangular prisms. So I'm going to cut this into the 2 prisms I know. I've got the green one and the blue one here. This might be easier for you if you draw them out separately with their labels. And gets us some practice in drawing our 3D shapes. So the green one is 10 inches by 30 inches by 10 inches again. And I got those 10 inches from here's 10. And also this is 10, so that means this must be 10, which means this is 10. So that's actually a square on the top and the bottom. So we do our volume equals big B times H. Well, the base is a square, so length times width times height. So volume equals 10 times 10 times 30. So that means volume equals 3,000 inches cubed. But that's just for the one rectangular prism. The other rectangular prism, wow, nope, let's draw this better. Remember, you start with a rectangle, draw diagonal lines going off the sides. Okay, the whole thing was 40, but we knew that this was 10, so what's left needs to be 30. I know this is 10 from this, and here the height is 12. See, 12, 12. So again, volume, it is a rectangular prism, so we use length times width times height. Volume equals 30 times 10 times 12. Get out our calculator. 30 times 10 times 12. 3,600. Last but not least, we are going to add them together. 3,000 plus 3,600 gives us 6,600 inches cubed. And remember, it's cubed because it's length times width times height. Inches times inches times inches gives us inches to the 3rd power cubed. All right, key concept. You can use formulas to solve problems involving the volume of 3-dimensional figures. You can use the formula volume equals big BH to find the volume of unknown dimension of a solid figure. Find the volume of a composite figure by finding the sum of the volumes of each solid figure. All right, 7th grade, let's say it for the last time this year. I can use the area of the base of a 3-dimensional figure to find its volume. Have a great day.